let's begin with minerals. Now, when we're talking about minerals, in the case of geology, we are talking about the building blocks of rocks. And over the years, humans have used minerals in many ways that they see fit. We can see in jewelry, they use gold. When we eat, we use salt, which is a mineral, and all other uses that minerals can give us. Now, how do we define what minerals are? For something to be a mineral, it needs to satisfy 5 conditions. So we are going to go through those 5 conditions and then look at some minerals and see if they abide by those conditions. Now, condition number 1, we say that a mineral must be naturally occurring. When we say something is naturally occurring, we mean that it is not synthetic. It is not made by humans. So it must come from natural geological processes. So it must come from natural geological processes, and it must not be synthetic or made from people. An example is, think about steel. Steel is not a mineral because it is made by people. It is an alloy that is made from mechanical processes. So steel is not a mineral. Now, after we say that it is naturally occurring, it must also be inorganic. Now, I know I already said naturally occurring, but trees are naturally occurring. So we want our mineral to also be inorganic. And by inorganic, we mean that it should not be made by an organism. That's what inorganic means. A tree can be naturally occurring, but it is organic because it is an organism. So organic, we say not made by or organisms. Now, if you take wood comes from a tree, so it would be organic. So it comes from an organism. Some interesting examples, let's say you take table salt. Now, table salt, which is the usual salt that you use in your house, it comes from a mineral halite. Now, from halite, we make table salt, and halite is naturally occurring and inorganic. Whereas if you have sugar, the sugar that you use in your house can come from sugar cane, and sugar cane grows just like a tree would grow as an organism. So sugar comes from organic processes, so it is not a mineral. So it must not be made from organisms, it must come from the ground. In some instances, there are some special minerals that actually come from organisms. Let's take a mineral called aragonite. Now, aragonite is a mineral that comes from oyster shells. Now, oyster shells are grown organically, but then they would become buried, and then we would find them over a period of time. And once we do that, then we say that they are from the ground, and aragonite becomes a mineral. The third condition for a mineral is that it must be a solid substance. And what do we mean? We say only solid crystalline substances are considered as minerals. So ice is a solid crystalline substance, but it is not a mineral. So you can have a solid crystalline substance but not a mineral. Why is that the case? That is because of condition number 4. Condition number 4 says for something to be a mineral, it must have a orderly crystalline structure. Their atoms are arranged in an orderly, repetitive manner. So if I were to draw it, I would draw a nice cube like this, whereby the atoms are nicely ordered. And once they become ordered like this in a repetitive manner, we begin to call them crystals. Hence, when you look at minerals, you would see them as some sort of glassy, nice and shining thing. An example of that will be something called obsidian. Now, obsidian is a black mineral. We call it volcanic glass. If you have watched Game of Thrones, they use it to kill the Night Walkers. They call it the dragon glass. Now, this volcanic glass, it will come with a crystalline structure and it will look shiny like it is some sort of glass. It is because of its structure and how its atoms are arranged. The fifth condition, a mineral must be able to be represented by a chemical formula. So once we know what atoms it comprises of, we must be able to represent its composition using a chemical formula. So an example would be quartz. Now the mineral quartz, the chemical formula for quartz is SiO2, whereby it is comprised of the silicon and also oxygen at a ratio of 1 to 2. After knowing the conditions of a mineral, how would we define a mineral? We would say that a mineral is any naturally occurring inorganic solid substance. It must possess an orderly crystalline structure and can be represented by a chemical formula. So a mineral is any naturally occurring inorganic solid substance that possesses an orderly crystalline structure that can be represented using a chemical formula. All these 5 conditions fall into the definition of a mineral. So how would we define a rock now that we know what a mineral is? Now, a rock has a more simpler definition to it. Is any solid mass of mineral. So any solid mass that has minerals in it, that can be a rock. So it can also be mineral-like. Doesn't have to strictly be mineral, and it must occur natural. So a rock is any solid mass of mineral-like matter that occurs natural. Now it can have a composition of different mineral. We call that aggregate. So it can be an aggregate of several minerals. When we say aggregate, we mean that minerals are joined, but they retain their individual properties. So it can have aggregates of several minerals. And by aggregate, remember that we're just saying that the minerals that you can find in a rock, they are joined together, but they still retain their individual properties. An example of a rock that is an aggregate of several minerals could be a rock called granite. However, in some instances, some rocks could have just one mineral in it instead of several. An example of that is limestone, whereby limestone also only has the mineral calcite. Therefore, even when you look at it, you just see one color, one uniform color throughout the stone. Whereas when you look at granite, you can see the different quartz, you can see the feldspar in the rock, so it will have multiple colors. In some instances, you could have a non-mineral rock. An example of that is obsidian. Obsidian is a non-mineral rock. It has an orderly crystalline structure. It is solid, it is inorganic, it is naturally occurring, but it does not have any mineral. We cannot represent these minerals using a chemical formula. And that's how you know what a mineral is.